today's session, let me quickly remind you what are the things we have discussed in your last lab classes. So, in your last lab classes, we are discussing about your predictive analytics using Python. Uh, first, what is the meaning of predictive analysis? So, predictive analysis is the technique, or you can say that is one type of statistical technique by which we are analyzing the current trend of the data or past trend of the data or historical fact to predict the future. Okay, so there will be some parameters like what will be the future cost after 5 years, what will be the future stock market values after 10 years. So those types of things can be predicted by these types of analytics techniques. Okay, so basically these techniques are used mainly in your marketing, business management, sports, insurance, telecommunications, retail, travel, etc, etc. So in many sectors they are used. Okay. uh, so what are the steps involved in your predictive analytics? So first is your define the problem, set up the problem. Next is your EDA, so your exploratory data analytics. That is that means you will be uh, first we have to, after receiving the data, we will be uh, finding out what are the important attributes available in that data. After that we'll be cleaning the data, means there may be some outliers, there may be some uh, null values, there may be some duplicate values, there may be some uh, errors also, or you can say there may be some noises. We'll be cleaning or we'll be uh, processing or pre-processing those data. Okay, and once those steps has been completed, after that we'll be checking the relationship between different data points. Okay, or you can say your relationship between the attributes, uh, how they are varying. Today I will explain what is the why I am saying that we have to check the relationship between different data points. Because if you are not checking the relationship and if you are directly implementing any model for our data set, then we may not get proper prediction, or our prediction may give us wrong result, or there may be several means huge errors. Okay, or you can say the score of the model will be very poor. So we have to check how the variables or the attributes of your uh, data set are related to each other. What is the pattern they are following? And according to that pattern, we have to implement specific models. Okay. today's today's example, you will understand it. What is the significance of this step? Okay. After that, will be doing some transformations. Okay. After that, we'll be going for model implementation. Means last time I told you linear regression model, logistic regression model, probability regression. Several models are there. So those models we can use to do future prediction. Okay. Next is your assess and implement. So these are the steps, basic steps involved in your predictive analytics. Uh, and I told you what is the meaning of your linear regression. So I have also shown you one example in which uh, these types of this example we are discussing last class, in which some data points were given to us, and based upon that data point we did some linear regression task, or we can say we tried to find out a suitable line that is called as a regression line, which will means on which all these data points can be perfectly fitted, or you can say uh, we'll be trying to draw a line through which means that line will pass through all these points. Okay, means our objective is like that. Okay, but practically what happens, uh, as these data points are not lying on a straight line, so we cannot have such a straight line which will be passing through all these lines. So we'll be drawing a straight line which will be passing some of these points. Otherwise we'll be drawing the line uh, in such a manner that the error, or you can say the distance between the line, or you can say your predicted points and the actual points, should be minimum. Okay, so that is the main technique behind this linear regression algorithm. Okay, so after that I also told you what is the basic difference between your linear regression and logistic regression. So basically, whenever continuous variables are there, at that time we prefer these types of linear regression models. And in your linear regression, your data is modeled using a straight line. Okay, whereas in your logistic regression, the variables are categorical type, means different types of categories will be there, means you can split these variables based upon their category, or you can say their types. Okay, and the output of this logistic regression is mostly probabilistic type, or you can say binary type, true false type, 0 1 type, like that. Okay, but whereas in your linear regression, your output of your variable is a value. Okay, means you will be getting, I have already shown you that we used to calculate your r square error. Okay, and we are also calculated your future prediction value. Okay, so we, in that we are getting finite values. Okay, there may be some fractional value, there may be some integer value or float type of value, but in this case, in your logistic regression, you will be getting the output like true false, yes or no type output. Okay, so these are the basic facts we discussed last time, and also we are discussing this point. So let me quickly remind you what are the steps involved in your linear regression algorithm. And uh, in your last class, I have shown you one-dimensional linear regression. One example I have shown you, and also told you the mathematical formulation, or what are the formulas used to implement this linear regression algorithm using Python. Also have shown you where how the prediction is done, and what is the technique for calculating this r square error. And today we'll be using same algorithm for a data set. Okay, first we'll be using, or first we'll be implementing this linear algorithm, linear regression algorithm on a small data set. Okay, and after that we'll be using this algorithm on a large data set. Okay, so the purpose of showing two data sets you will understand later, because I'll show you whenever we are going to large data set, we have to we cannot arbitrarily, or we cannot just apply this linear regression algorithm on any data set. We have to pre-check all those things. We have to check patterns of all the variables, and based upon that we will be uh, deciding whether it is good to use these linear regression algorithms for that data set or not. Okay, so I'll explain you just after some time. So these are the steps involved in your linear regression algorithm. So first there will be some training samples will be given. So training samples are used to train the model, or to create the model. You can say, means those are the reference things, or uh, given value for us, and based upon that we will be creating the model. Okay, and basically we'll be trying to draw a straight line. So first we have to calculate the mean of those training samples. Here you can see this is the x and corresponding y values are given, and the mean value has been given here. Okay, and once your mean has been calculated, you can calculate your slope. Okay, so slope is given by this formula. Okay, and this formula I have already told you how these formulas have been derived. Okay, so using this formula we can calculate your slope, and once we have calculated your slope, then you can see slope value has been calculated here, 4 by 10. Okay, once you have calculated your slope, we can calculate your y-intercept by using that mean points. Okay, so mean points means mean of x values and mean of y value. We can use that point to calculate your corresponding y-intercept, or c you can say. Because why we are using this point? Because these mean values has been used to calculate your slope of that regression line. Okay, so here you can see that thing has been done. Okay, so from this equation we can calculate your c value. So once we have calculated your c value, we have both the parameters available, like your m and c. So we are having a straight line equation. So once we have your straight line equation, then we can go for your predictions. Okay, you can see we'll be using same training samples for doing the predictions, because we have our original value given, and now we have uh, developed the regression line. Okay, and based upon that the regression line, we'll be calculating our prediction value. Here you can see these are the predicted values. Okay, and once you have calculated your predicted value, after that we'll be calculating your errors, because you can see that these predicted values are not lying or perfectly lying on this straight line. There means there are some errors definitely present in all the cases. So we'll be calculating these errors. Okay, so these are called as your, you can see this difference or distance are called as your errors, and those are called as your means the process of calculating that error, or you can say the score of this algorithm is called as a R square error. Okay, so for calculation of your R square error, we'll be using this formula. Okay, so once we have calculated this R square error, from this we can find out how good is our model. Okay, so if your R square error in the previous, means in this specific example, we calculate your R square error as your 0.3. So if we are getting R square error as 0.3, that means our prediction is far apart from the true values. Okay, means there is uh, definitely huge error is present. Okay, so you can see all these predicted points, these points are not lying on this straight line, they are far apart from this uh, regression line. Okay, so if you are trying to increase this R square error by anyhow, okay, so there are some techniques I told you, like your gradient search algorithm or points and lines techniques. If you are trying to uh, in, you can say improve your accuracy of your model, suppose you are getting your R square value is equals to zero point 0.7, then what happens, your prediction points or predicted values will come closer to your regression line. Okay, if it is this R square value reaches close to your 1, then they will be lying on this regression line. Okay, so this is the thing, our objective is to uh, get your R square value as close as possible to 1. So these are the mathematical technique, or you can say a mathematical background which has been used to implement this linear regression. Okay, so this is the code. I have already uploaded this code in your GitHub. You can use that. So today, what happens will be using this linear regression algorithm for prediction of a data set. Okay, so let me tell you what is the data set we are going to use. So this is the data set which we will be using today. So first, uh, this is a very small data set. Okay, you can see. Uh, uh, Let me show you the actual data set. Okay. Yes. So here you can see this is a very small data set, and in one column you can say mileage is there. Okay, and next column average years of use is there. Okay, and in next column sell price in dollars is given. Okay, American US dollars is given. Okay, so 20 rows are there and 3 columns are there. Okay, so the thing is that mileage is given to us, average years is given to us, and here uh, sell price, this will be acting as your dependent variable, and these two things, these two variables or these two attributes will be used as your independent variables. Means basically this is the trend given to us, and based upon this trend we'll be trying to predict the price or selling price of this vehicle. Actually this is the data of a BMW car. Okay, we'll be trying to predict the selling price of a uh, vehicle based upon its mileage and average years of use. Okay, means these are the things given to us. So if some extra data, or you can say some mileage or your average value, average years of use is given to us, then what will be the corresponding selling price we have to predict. Okay, so that is the technique, means that is the question here. Okay, so in this case we'll be using your linear regression model to do that type of prediction. Okay, so this is a very small data set, and it's very easy to understand. This is very easy to understand. Okay, so from this data set we'll understand what type of relationship we'll be looking for before going to implement these types of model. Okay, because in realistic, or whenever we are going for real data analysis, the size of the data will be very large. Okay, here what happens, only two independent variables are there, well, and one dependent variables are there, but in a real case, uh, dependent variables most of the cases remains one, but the independent number of independent variables are so many. Okay, here two are there, there may be 20 variables. So based upon that 20 variables, we'll be trying to predict this one dependent variable. So uh, I will tell you what type of problem may occur or happen in these types of things. Okay, so this is the data set we'll be using to predict the thing. Okay, and what happens for this what about example we discussed in your last class, that was a you can say that is one dimensional case, but in this case the dimension has been increased because you can see your number of independent variables have been increased to 2. So here the complexity has been increased little bit. Okay, so for handling these types of things you can also write your own code, but we are not going to use our own code. We'll be using some of the facilities, or you can say some of the functions that is available in your Python, and that is given by your scikit-learn library. Okay, so basically scikit-learn library is a inbuilt package, or you can say your library, that is exclusively used for your classification problems, your regression analysis, and your clustering problems. Okay, so this is the homepage of your scikit-learn library. Okay, if you're just uh, typing scikit-learn on your Google, you will find this page, and you can search inside that what is the exact thing available here. You can see in this case NumPy library, your SciPy library, your Matplot library, Matplotlib library. So all these things have been embedded in this one library, and it is a very powerful library that is used for mainly machine learning purpose. Okay, so today I will be showing you some of the important functions those are used for our these types of regression analysis. Similarly, so many other functions are there. You can use them for your project purpose or for your task. Okay, this is also open source, so anybody can use that one. So you can see same whatever dataset I was showing. So some portion of that dataset is shown here, and practically what happens whenever we are going to use your scikit-learn library, uh, these types of dataset will be using, and first we have to choose some of this portion of this dataset for your training purpose and rest of the dataset for your testing purpose. Okay, so here you can see, suppose you can see 4 5 7 10 entries are shown here. Okay, suppose 10 entries are here, and this is the given data set. Then what happens, we'll be using 80% of this data set for our training purpose, rest of the 20% for our testing purpose. Okay, means uh, we are not going to use the whole dataset for our training. Rather, we'll be using some of its portion for our training purpose, and rest of the things we'll be keeping them for our testing purpose. Okay, so for splitting these things, we'll be using one technique that is available in your scikit-learn library, that is called as your train test split library. Okay, you can train test split technique. Okay, so this is one type of function that is available directly in your scikit-learn library. So we'll be using that to do that type of splitting. Splitting means we'll be splitting the whole data set for two purpose. One will be used for our training purpose, means that will be used for developing our model, and rest of the things will be used for our testing purpose. So this is the link given here. You can use this, means go to this link and check the details of this technique, trends test split technique. Okay, so most of the cases what happens, we use 70 to 80% of our total data set for our training purpose, and rest 20 to 30% we use for our testing purpose. Okay, so let us go to the spider and start executing the program so that you can understand what is going to happen. Yes, so I have already written the code here, so we'll be directly executing all these things. So first let us import the libraries. What are the required library? So first we'll be importing your pandas, your NumPy, though NumPy is not required if you are using this this scikit-learn. Still I've just written it because it is already available there. Matplotlib library. Okay, so error is given, no name is given, so that's why that is the error we are getting. Okay, so we have imported the library, and next let us import the Excel file, okay, or you can say your CSV file, data file. So this is the address. This is the means the you can say the location of your file. Okay, uh, and what happens? You can see we are using this pandas library to read the Excel file. Okay, and whatever data are available in that Excel file, that will be copied to your this variable that is called as your data. So data is a multi-dimensional variable inside which all the contents of your Excel file is going to be copied. Okay, so this task is completed. Next we can check what are the so here what happens once you have copied your data or imported your data, we'll be checking uh, the characteristic of your complete data set, means what is the size, how they are varying, because those are very important. After few steps you will understand what is the main use of your EDA. Okay, so let me show you. So first let us see what is the size of this thing or what are the initial entries. So data head, you can see first 5 rows have been shown here, and means and your these are the columns. Okay, uh, so these are the small things you can check. Okay, next uh, what happens, we'll be checking the relationship between these variables. Okay, means you can see two independent variables are there, like your mileage and average years. One dependent variable is there, that is your selling price. And what happens, we are going to predict this selling price or the value of this dependent variable based upon the values of these two independent variables, that is your mileage and your average years. So right now we'll be checking the relationship between this independent variable with your dependent variables, how they are varying, and this is the most important step in this total process. Okay, so first let me copy this step. You can see, so we'll be checking the relationship, means we'll be drawing the graph and we'll be checking how they are exactly varying. So we'll be just plotting a scatter plot. You can see plot dot scatter is there. So this thing, you can say this thing with this means we are using this thing because we have already imported this MATLAB plot library. Okay, matplot library. Okay, so this is the facility given by this library. So you can see in one axis mileage is there and in another axis sell price is there. Okay, so you can see this is the graph. Okay, and in this case this is in one axis your selling price is there and in another axis your mileage is there, and you can see these points are varying linearly. Okay, so you can see if you draw here in this case we can draw a line through which hello,
spider
yeah,
not visible, sir.
sorry,
Your PPT is visible, but it is a spider practical
PPT.
work. Yeah, practical work is not visible, sir.
Okay, okay. Uh, okay, PPT is visible. You are saying. Okay, let me. Is this visible right now?
The PPT is only visible, sir.
Okay. I'm doing something. Just a second. Okay. Is this visible right now?
Yes, sir.
Yes,
Okay.
sir.
Thank you for telling me. Okay, let us start this once again. So here you can see, first we have imported your libraries. You can see from this we have started actually. We have imported your pandas library, we have imported your numpy library, we have imported your seaborn library, and also we have imported your matplot library. Okay, and after importing your library, after that we have we are tried to means we read your Excel file. Okay, so this is the Excel file I have already shown you. Book one, the name was book one, and this is the location of the file. And after reading the file, whatever contents are available in that CSV file, those has been copied to this variable named as your data. Okay, and after that we have just checked what are the first 5 entries using this data dot head. Okay, so next you can do other things also. You can check the whole size of the data set. You can check the last 5 entries. You can say, you can also calculate the you can say the mean, your you can say the uh, means what are the things we have studied, you can use that data dot describe command to find out your mean, your 25% value, your max, all those things. Okay, so next, this is the important step, that now we are going to check the relationship between your dependent variable with your independent variable. You can see these are the two things, your mileage and your average years. These are the two independent variable, and your sale price is your dependent variable. Why I am saying your sale price is dependent variable? Because we are going to predict your sale price of this vehicle based upon the mileage and average years. Okay, so basically you don't have any control over these two parameters, like your mileage and average year. That will be given to us. Okay, and based upon that data we'll be trying to predict the what will be the selling price. Okay, and here first we have plotted the relationship between your mileage with your sale price. So this is the thing, we have just plotted that one. So this is a scatter plot dot scatter, and inside this in one axis your mileage will be there, data mileage will be there, and another axis data sale price will be there. Okay, and this is the graph. Okay, and here you can see these variables, means these two variables are varying mostly linearly. Means if you are trying to draw a straight line, then we can have a straight line which will be mostly passing through means which will be passing through some of these points. Or you can say a regression line can be drawn for our prediction purpose, because these are uh, you can say more or less varying linearly. Okay, similarly let us check the relationship between other two variables. Okay, why I am checking this relationship you will understand in the next example. So you can say plot dot scatter, and here I'll be checking the relationship with your average years with respect to your selling price. Okay, so here also same type of thing is there. Means these are also means here also they are varying linearly, mostly linearly. We can have a linear regression line uh, which will be passing through, mostly passing through most of the points. Okay, so from this thing we can imagine that uh, our independent variable means our dependent variable is varying linearly with two dependent variable sorry, our dependent variable is varying linearly with the two independent variables. So once this thing we have evaluated, or this pattern we have seen, after that we can think that yes, if we are using linear regression line, then we may have some better prediction in this case. What happens if we are finding that some of the variables, like suppose your dependent variable is not varying linearly with respect to your independent variable? At that time, if you are using these types of linear regression line or linear regression technique, at that time your prediction will not give you proper result. Okay, so that's why we have to check the relationship between these variables, how they are varying. If all these things are varying linearly, then it's better to go for this linear regression technique. If they are not varying linearly, then there may be the possibility of some you can say poor prediction. Okay, and here also uh, so these are the relationships. So next, let us do one thing. We will be using two variables to assign these things. Okay, so we are using this x as a variable in which we'll be storing the mileage and your average years. Okay, means initially what happened, everything means all the data set has been copied to this data, but in this case we'll be splitting the data into two parts, and we'll be storing the mileage and your average years in another variable, that is your x. Okay, you can also check the values also. X is containing your two variables, mileage and average years. Okay, similarly will be means this is the you can say x is your independent variable. Okay, so that's why we have just separated them. Okay, next let us separate this dependent variable also. This is your y, and in this case we are keeping your selling price. Okay, you can also check whether that is available or not. Okay, so we have just splitted your independent variable from your data set, and also uh, dependent variable from your data set. Okay, so next we'll be using your scikit-learn library for splitting purpose, because this is the complete data set, and here you can see 20 number of entries are there. And I have already told you, whenever we are going to use your scikit-learn library, we will be using one technique, that is your train test split technique. So in that case, what happens, we'll be choosing some of its portion for your training purpose. 70 to 80% of data will be used for your training purpose, and rest of the data will be used for your testing purpose. So let us import that one. So first we are importing this trend test split technique from your scikit-learn library. Okay, next we'll be using this command to assign that that thing. Means here you can see this is the syntax for using this trend test split technique. So in your left side, okay, you will be having four parameter means first will be x trend. Okay, what will be the uh, external values, means how means what are the what are the things will be present. I will show you what exactly happens. After that, another variable will be there, which will be x test, and next will be y trend, next will be y test. So four variables will be there, and we are going to split the whole data set according to this one. So inputs will be your x variable and your y variable, means whatever things are taken here, x and y will be taken as your input, and test size is equals to 0.2. That means 20% of this dataset will be assigned for your testing purpose, and rest of the dataset will be taken for your training purpose. Okay, so once this code has been executed, you can let us check this one, s underscore train. Okay, so here you can see, here I have already told you that 20% of the dataset will be taken for your testing purpose. Rest of data will be taken for your training purpose. So what are the values available in your X? These are the values available in your X. So after using that technique, 20% has been taken for your testing purpose, and rest of the 80% are available for your training purpose. 80% of 20 means that is just 16. You can see 16 entries are there. Okay, so these will be used for your training purpose, and here also you can check X test. So these are the four entries which will be using for our testing purpose. Okay, so similarly you can also check your Y also. Okay, Y train, Y X, Y train and Y test. So this is the Y value. Okay, 16 entries are also there. Okay, similarly Y test also you can check. Okay, so the thing is that now we are going to use this linear regression model based upon these 16 values. Okay, and these four values will be used for our testing purpose or our prediction purpose. Okay, so you can also check the length also. What is the exact length? You can check here also, length of your external.
Sir,
So 16. Yeah.
sir, how does it classifies, like how does it take values for testing purpose, sir? Like, is
Yeah,
there any like criteria to select selected values for training and testing,
I'm telling,
or
I'm
it will
telling
take random?
randomly. Okay, so what happens, usually if you are using this trend test split technique, then you can see these numbers has been written to 2, 11, 0, 10, like that. So it arbitrarily chooses the value. Okay, if you are using this technique. Okay, and what happens if you are repeatedly executing this code? Okay, you will see that these values will be changed. Okay, so if you're repeatedly executing this code in your if you're going to online platform and repeatedly to executing this code, you will see this data selection will be arbitrary. Okay, so to make it fix, okay, you have to use another code that is called as, means you have to use another parameter here, that is that is called as a random state. Okay, so if you are using that random state variable here, means random state equals to 10 or some finite values, then it will fix this selections. Okay, if you are repeatedly executing the code, it will not vary. Otherwise these things are going to vary. Okay, and here the selection is done randomly. Okay, there are also some other techniques, means other functions by which you can also select first 10 entries, first 20 entries, or first 80% entries. Okay, so I will tell you to explore those things. Okay, so next, so already we have seen what are the things available in your trend test thing. Okay, so we'll be using this linear regression technique. So let us call this from your scikit-learn library. So from scikit-learn library, we'll just calling your linear regression. Okay, so first we have to perform your linear regression. So whatever calculations are going to be done, that is going to be stored in your this variable, that is your range. Okay, so after that what happens, we'll be trying to fit the variable. Okay, and what are the things we are going to fit? We'll be fitting your x trend to your y trend, because we are going to model the thing based upon this x trend and your y trend, because we have already splitted the x variable and your y variable with a ratio of 80 to 20%. Okay, so we'll be using that 80% of the value for our trading purpose. So that's why you can see range dot fit in your bracket x trend and y trend is there. Means these two combinations, or you can say this 80% of values will be used for modeling your uh, means modeling this one. Okay, for modeling the system. Okay, so after executing, you will get this output, means it is correct. Okay, once this thing has been there, after that we'll be predicting the thing, and we'll be predicting based upon this 20% value. Okay, so whatever things are there in your x test, we'll be using these inputs for our testing purpose. Okay, so here is the thing. So range.predict means we are basically trying to predict, and this prediction is going to be done using this x test value. So whatever 20% or 4 values are there in your x test, those will be used for our prediction purpose. Okay, same thing means here what happens in most of the cases, if the data is some additional data is not given to us, we can extract some of its given data, and we can use that thing for our checking, or you can say for our testing purpose. So that is the thing done in this test, you can say your in this library, that is or in this technique, that is your trend test split technique. Okay, so these are the outputs, or you can say which we often after your prediction. Okay, you can see the values are something 16,950. Okay, let me write down your uh, y test also, so that you can understand what are the values we have predicted. You can see these are the values given to us. Okay, and these are the values we have predicted based upon the model. Okay, you can see here the original value which was given was 19,400, and according to our prediction, according to this linear regression model, this value we are getting, that is your 16,950 US dollars. Similarly, originally it was given your 12,800, and we are getting 15,572.9 $9076. Okay, so you can see there is not much error in this model. Okay, so this prediction is nearly similar to the values given in our data set. Okay, so definitely we are going to get some good score. Okay, so here we have completed our prediction task. Next, we are going to check our accuracy of this model. Okay, so for that we'll be checking the score. Okay, so this score means this technique means this function is basically calculating your r square error. Okay, whatever r square error we have calculated in your last class, same technique is here, but the changes are, in that case we have developed or we understood or we discussed the thing of a one-dimensional case, but in this case we are discussing your multi-dimensional case. Okay, means the independent variables are more than one. Okay, so here you can see the value, or you can say the r square value we are getting, that is your 89%. Okay, so 0.8984 is there, that means it is 89%. Okay, that means whatever linear regression technique we have used here, that is very good. Okay, and that predicts very accurate. Okay, and the score is very good, and this is happening because we have already seen this is happening because all this means this dependent variable is varying linearly with respect to these two independent variables. Means in both the graphs we have seen they are varying linearly. That's why this linear regression model fits very well with this problem or with this data set. Okay, and this is all about this thing. Means from this you can imagine how we can use this scikit-learn library. Now I'll be showing you another example or another data set, and we'll be discussing what type of problem may happen if your uh, dependent variable is not varying linearly with respect to your independent variables. Okay, because whatever model we are going to implement, that is decided based upon the data set. Okay, because if your data set is something different, if it is varying in some different manner, we have to predict which types of models should be used. Okay, it's not like that in every model we can use your linear regression type or we can go for logistic regression. We have to check the patterns how they are varying. Okay, sometimes in this case also we may have to use your polynomial fitting techniques. Okay, instead of going for this linear variation linear regression, we have to go for your polynomial regressions also. So it depends upon the data set. Okay, so let us use on another data set. So let me show you the data set first. Okay, yeah. So this is one data set which I have downloaded for your from your Kaggle. Okay, and you can see there are number of columns are there, date, price, bedrooms, and you can also download this dataset from your from the Kaggle. The you can just type your house dataset. Okay, so you will get this one. So date, price, bedrooms, bathrooms, square feet living, square feet lot,
Sir,
square. Yeah, please.
sir, your PPT is not visible. You are on spider only.
Okay, okay. It's not changing actually. Okay, don't worry. I'll be importing one data set. After that, you will see there. Okay, don't worry. Okay. Okay, so I'll be just importing another data set here. Uh, so let us. Uh, the spider is visible. There is no problem with the spider.
Yes, it is visible.
Okay, okay. So we'll be importing some other data set. Okay, so let me uh, first let me copy this one first. Okay, so same thing we are going to do here also, but the data set will be changed. Okay. So first we have imported this library pandas, numpy, and seaborn. Next, let me copy this. Okay. So this is the okay. Let me copy the address of this file. Okay. So the name of the file was your house. So the file has been imported, and whatever content was there, it has been copied to data. So so we'll be doing a couple of steps to check what are the contents in your file. Okay, so data.head. So here you can see means first five rows are there, and the size is given like this: 5 rows, 18 columns. So basically, in this file, 18 columns are there. Okay, and okay, let me show you the file once, because that will be that is required. Uh, okay. Okay. Is this file visible right now? This Excel file?
Yes, sir. Yeah.
Yeah, you can see 18 columns are there: date, price, bedroom, bathroom, square feet living, square lot, floors, waterfront, view, conditions. So like that, 18 columns are there, and at this end, just remember that some of the entries are there, like your street. Okay, these are the address. Okay, address of this house, city, state, zip, and country. Okay, so basically what happens, you can see in this second column we are having price. Okay, we are going to predict the price based upon these conditions, based upon your bathrooms, bedrooms, your square feet living, square lot, floors, waterfront, view, and whatever parameters are there, they will be acting as your independent variable, and we are going to predict this dependent variable, which is your price. Okay, means what will be the price of the house which is having this number of bedrooms, this number of bathrooms, this number of this value of square feet living, like that. Okay, so so if you are comparing this data set with your previous one, this is mostly similar, but only one difference is your number of independent variables are huge. Okay, you can say 15 or 10 or 12 or 13. I don't know. Okay, so means we'll be predicting that one, means which will be suitable for our purpose. Okay, so so is this slider visible right now? Hello, can you see
Yes,
the
sir.
spider
Yes.
screen? Okay,
Yes.
so yeah, so by using your data.head, we can see the first five rows, first five entries. Okay, you can also use your data.tail. Let us use this shape. Okay, so data.shape, so that which will show you the overall size. So there are 4600 rows and 18 columns are there in this complete data set. Okay, you can also uh, use these columns to see what are the column names. Okay, so these are the column names. Okay, so after that will be you can also check whether there are some null values are there or not. Okay, so in this data set no null values are there, so they are perfectly clean. So we don't have to do that processing. But here first let us check what are the how these variables are varying with each other. Okay, so this step I told you, this is a very important step. So you know, last example also we did same thing, and now let us do that one. So here basically we'll be plotting your price with respect to your bedroom. Okay, and the thing is that in the previous code what happened, we are using your scatter plot, because we are using your let me show you that. You can see we are using this scatter plot technique. Okay, so plot dot scatter. Okay, because we are using your matplot library, but in this case what happened, we are using your cbon library. Okay, because we are not using your matplot library, we are using the cbon library for plotting purpose. So that's why sns.replot is there. Okay, so this thing is used for your plotting purpose, sns library or cbon library. So we'll be plotting your price with respect to your bedrooms. Okay, let us plot it. So this is the variation we are observing here. You can see in this case price is there, and in this y-axis bedroom is there, And the problem is that most of the values are accumulated in this region. Okay, and whenever we are moving here, there is very few values are there, and whatever values are here, they are not varying linearly. Okay, so that is the thing we have to check whether these variables are varying linearly or not. Okay, so let us check another variable. So here we'll be plotting your square feet living with respect to data. So if you're plotting that one, you can also see that they are also not varying linearly. Okay, they are also accumulated at a specific point. Okay, at this point. Okay, at lower price value, they are accumulated here. Okay, so they are not varying linearly. So in this case, what happens if you're finding that most of the variables means your dependent variable is not varying linearly with most of the independent variables, at that time you should understand that there may be a chance of getting poor score or bad prediction if you are using these types of linear regression model. Okay, because we cannot draw a line which is going to fit with all these things. Okay, so that type of problem may happen if you are using this linear regression model. So let us use linear regression model and check what type of means how much poor result we may get in these types of things. Okay, and so okay, so let us import this linear regression and your train test split technique from your scikit-learn. Okay, so these are the two things already we have used. Okay, and what happens after that, uh, as you have done means as you have splitted your independent variables and your dependent variables last time, same thing we will be doing here also. Here uh, instead of x I have just written, or here it is written like train. Okay, that means this is one variable, and in this variable I will be dropping some of the columns. Okay, because what happens, price will be taken to our dependent variable. This train is going to be used as your independent variable, and in this case we don't need your price, so that's why I am dropping this column. You can see data dot drop is there, means this price column will be dropped, and date is not going to be used for your calculation, because that is because we need the cost should, or you can say the price should be evaluated with respect to the bedrooms, number of bedrooms, bathrooms, and all those things, and date is not a valid parameter for that. And address, city, state, zip, these are some of the entries which are not going to be used for our calculation, because they are containing, you can say they are containing some you can say they are string values, and they are not used for your calculations. Okay, because we'll be using some mathematical technique, so they cannot be used for your calculations. So that's why the street, city, state, zip, country, your these parameters will be just dropping these columns here. Okay, so you can see after dropping uh, uh, the data has been stored in your train. Okay, so next let us call this linear regression. Sorry, okay, we have defined the this is your independent variable. Let us define the dependent variable. Here the name has been given differently, so train and test, but you should understand that this is your this train is your capital X, which you have taken last time, that is your independent variable, and this is your dependent variable. Okay, so in your dependent variable only price is kept. Okay, so next let us call this train test command. Okay, so this function, uh, x train, x test, so for that four parameters are there, and we'll be using this function. Okay, and your input variables x and y are given, train and test, and test size has been taken as your 0.3. Okay, that means 30% of your value will be used for your testing purpose, and 70% of your values will be used for your training purpose. Okay, and you can see random state is equals to 2 is given. That means we are fixing that one. Okay, means if you are executing this command repeatedly, then that is not going to change. Okay, then let us call this regression linear regression command. Okay, and after doing this calculation, that is going to store in this linear regrx. Okay, this variable. Okay, so after that we'll be doing that fitting. So these steps we have already done last example. So fitting, will be fitting the x train with your y train. Okay, this step has been completed, and after that we'll be doing that prediction. So prediction, you can see we'll be predicting with respect to x test. Okay, so prediction is completed. We can also check what are the prediction value we are having. Okay, so these are the values we are getting. Okay, so you can also check like your x test y test value. So you can see how they are varying from these values. Okay, so initial some contents you can check. So initial means our prediction says that the value should be 33 okay, that is your 3,30,495, whereas here the value was 2,32,000. So there are some errors. Okay, so let us check what is the score we are having here, because from this thing we cannot say whether your prediction is good or not. We can predict that thing from this score. So this is the thing that you can see your score is only 9% here. Okay, or you can say your you can say the value we are getting 0.09, that means 9% is there. That means uh, for this data set, if you are directly using your linear regression model, then that is not going to give you good prediction. Okay, so in the previous case, what happened, we have seen all those variable, all those your dependent variable was varying linearly with respect to your all those independent variables. But in this case, we have already seen the trend. We have already checked that they are not varying linearly. So if you are trying to fit using a linear regression line, then it will not give you uh, good prediction or good score. Okay, so for that, what happens, we can do some modifications, like you can try all those things. I'm just showing you. So here we have considered these parameters also. You can see year of build, year of renovations, they are also have been used for your calculations, but they actually they don't have any contribution for your calculation of that uh, price. Okay, you can also remove those columns also. You can see whatever that dropping command is written here. You can see here. Okay, what happened there? Yeah, here in your training data, you can also input some other columns also. Okay, like your these things you can also remove from your calculations. Okay, and you will see if you are removing these things, then definitely your score is going to improve. Okay, but it's not like that it will instantly it will give you 50%, 60%, or 90%. Okay, you have to properly choose these variables, which variables are actually needed for your calculation of the price. Okay, or you can say we have to properly choose the variables which are varying linearly with respect to each other. Okay, so if you are properly choosing those variables, then only you will be getting good fitting or good score. Okay, so that's the thing, that you have to check how these variables are varying with respect to each other. Okay, based upon that you have to decide which types of models you should use. Okay, because if continuously variables are varying, then you can go for regression model. But if they are not varying continuously, then we have to also change the model to logistic type. Okay, because in that case, if your variables are categorical type, we have to move to your logistic models. Okay, so these are the thing all about your how to use your the scikit-learn library for your linear regression model, or you can say your simple linear regression model. You can explore other functions also. There are so many other beautiful functions, or you can say powerful functions, which you can use for your purpose. Okay, so these are the some of the basic things, and there are some there are also some you can say thumb rules which are usually followed for choosing these types of models. Okay, you just search all those things. Those are available online. Okay, so you can use for your model. Okay, so this is all about your predictive analytics. So next class we'll be having the discussion regarding your J component. Okay, and let me tell you one thing. So in your J component, uh, your project should contain three things. Okay, first is your system design. Okay, system design means IoT system design. It may be your healthcare system or your agriculture system or your traffic control system, whatever type of system you have developed your last semester lab classes. Okay, same type of system will be there. There must be some novelty. Okay, and along with that, uh, you will be collecting the data. Okay, whatever data you will be collecting, you will be trying to store that data in some cloud platform. Okay, that may be your open cloud platform. You will be storing that thing in your cloud platforms, and after storing that thing in your cloud platform, you will be using some analytics. Okay, for your prediction purpose, or you can say for optimization purpose, or some forecasting purpose. So you'll be doing some analytics based upon your problem. Okay, so these are the three things: system design plus cloud storing plus some analytics. Three things will be there in your project. Okay, so definitely this time your project will be having more tasks as compared to your previous time. Okay, previous time you might have done a simple system design problem, but in this case something more has been added here. Okay, so in today yeah, today or tomorrow I'll be sharing the file, means your Excel file, uh, regarding your group members. Okay,